All right, we've got two more flow charts, and these are both going to be utilizing side angle side. I'm going to do these side by side so that I can show you how they're slightly different, okay? So for the first one, I'm going to go ahead and put in our three boxes, side angle side. And the angle part's easy because we see that the 52 degrees for the C and the U are going to match up. So angle C is congruent to angle U. That part's done. And then we're just going to match up our sides. So our longest side on the top is EC, which is 30. Our longest side on the bottom is UW, which is 70. And when we simplify that fraction, we get 3/7. And our shortest side on the top is CD, which is 15. And our shortest side on the bottom is UV, which is 35. And again, when we simplify that, we also get 3/7. Okay? Now, if you don't believe me, you can pull up your trusty calculator, make sure you get the same decimal, 0.42 and 0.42. Okay, so 3/7 and 3/7, so all that checks out. So we've got our sides matching up here, our angles congruent. We now have proven this. We've got our evidence pieces. All we have to do now is finish our similarity statement. So we've got triangle UVW is similar to triangle. Well, what matches up with U? We said that C matches up with U. So C needs to come first. And we went from U to V. We went along the shorter side. So if I'm starting at C, I need to also go along the shorter side. So C to D. And lastly, that leaves E. Okay? So that's how you do it if the triangles are not attached. Now, in number 19, we're going to have a slightly different scenario. It's still side angle side, and our sides work the same way. We're going to pair up our biggest side, DF, which is 42, with 7, which is CD. Okay? And 42 divided by 7 gives us 6. And we're going to pair up our shortest side on the top, ED, which is 30, with DB, which is 5. And when we divide those out, we also get 6. So our sides work out, and they're exactly the same every time we do sides. Okay? Now for our angle, there's a problem here because none of our angles are marked. So the first question is, if we're going to use side angle side, first of all, we have to know that there is an angle congruent to another. Well, if you remember from our angle relationships, anytime two lines intersect, they create a vertical angle. So the angle at the bottom and the top of these triangles are going to be congruent. So we know that by the vertical angle theorem, those two angles are congruent. But how do we name those angles? If we look at the top angle, we know that this is letter D here, but if I say D, am I really referring to the top angle, or am I referring to this bottom angle right here? And we don't really know to be sure. So, to differentiate, we have to use the other letters in the triangle. So for the top angle, we're going to name that angle EDF, because drawing the path of EDF creates that middle angle. And that's going to be congruent to angle CDB. And of course, you could have drawn your path the other way and said angle BDC. As long as the D is in the middle, either one of those ways works, okay? All right, so we've got all of our pieces. Now we just need to write our similarity statement. So we've already been given triangle DEF. So if we're trying to create a similarity statement where the angles match up, we know D and D match up. And if we're going from D to E, we're taking the shorter path. That means I need to go from D to B. And then lastly, of course, we have C. So these are two slightly different ways that the side angle side theorem can be done. You just need to be very careful when you're naming your angles.